Hey, this is Mr. Ng going over the Math 5 Chapter 5 test taken on April 3rd, 2018. This covered Chapters 5, Section 1 to 5.6. If you were given the version A, C, or D, this is the video going over those. The test was out of 32, not 34, and that's reflected on Aries. Question number 1, determine the product of h of x given the linear and quadratic factors. So it tells you product. So you should be thinking about multiplying f of x and g of x. So 4x minus 1. Notice how the minus 1 is associated with the 1 there. And then g of x here I put on top. Now it doesn't matter, but here you can do multiple multiplying of FOIL or anything like that. So 4x times negative 3x squared is negative 12x to the third. You multiply the constants, numbers in front, and then the exponents you actually add. So 1 plus 2 is 3. 4x times negative 2x is negative 8x squared. 4x times 5 is 20x. Negative 1 times negative 3x squared is positive 3x squared. Negative 1 times negative 2x. Positive 2x, negative 1 times 5 is negative 5. I put them all out here. You also notice in the box method area model that if there's no missing terms and they're in descending order, then diagonally you'll see the like terms. So negative 12x to the third, 3x squared and negative 8x squared, that becomes a negative 5x squared. 2x and 20x is 22x and negative 5, so that would be choice A. Some student work of a student showing the area model correctly. Question number 2, multiple choice, determine the number of zeros possible for p of x. So here's p of x, it tells you x to the fifth plus 4x to the third minus 2x squared plus 10. You'll notice that this is in descending order of your polynomial. The reason why it's descending is you look at the exponents, 5, 3, and then 2. And I circled the largest degree, which is 5. This tells you the max number of x-intercepts or zeros. So in this problem, that means you can have 5 or less, 5, 4, 3, 2, 1, or 0. D would be incorrect because remember this number matches the number of zeros. This is too many, and this one doesn't have a cap. Question number 3, multiple choice. Determine algebraically whether the function is even, odd, or neither. So here, notice how it does not say the word degree. So how do you test for a function algebraically? Well, every x value, you're going to substitute a negative x for every x value. So here, every x value, you're going to put in a negative x. And then here you use PEMDAS to simplify. So negative x times negative x times negative x times negative x, that gives you x to the fourth. Here this becomes x squared, because I'm doing exponents first, then multiplication, which is like a negative 1 times x squared. And you'll notice that here I have negative 3x to the fourth minus x squared, which is the original function. So the answer is A. My hint for that was evenly. Now if you could factor out a negative 1 from here, meaning basically you multiply the original function by times negative 1, the answer would have been odd. That's called odd x, or if it's neither even nor odd, that would have been neither. Question number 4, find the function f whose graph is given below. So here you should recognize that all of my graphs are in factored form. My functions are all in factored form. I know that because there's a bunch of parentheses there. Okay, so I just have to match up my graph. Now, some things I should notice. The end behavior, starting up, ending down, means that they're not in the same direction, so it's going to be an odd degree. Normally, cubic functions or an odd function starts down, ends up, such as in question number 5, but it's reversed. So that means that my leading coefficient, LC, is negative. Now I'm going to go through each of the x-intercepts. So here at negative 1, x equals negative 1. Remember, if you add 1 to both sides, you have the factor x plus 1 equals 0. And there, because it's going through or shooting through st, that's an odd multiplicity. So for example, x plus 1, that's the one above it. Here going through 0, same thing, x equals 0, shoot through, you have an odd multiplicity. Here it's shooting through, x equals 1. Remember we set it equal to 0. Subtract 1, x minus 1 equals 0. That's a shoot through. That's an odd multiplicity. And then here you notice you have a kiss or a bounce at x equals, that's wrong. That should be x equals 2. So we should have it at x minus 2. So your multiplicity is even, that'll be here. So this represents x equals 2, x equals 1, x equals -1, and x equals 0. There's your leading coefficient that's negative, and your multiplicity is 1, 2, 3, 4, 5. Question number 5, multiple choice. Identify the end behavior of the polynomial function f of x equals x cubed minus 3x squared minus 2. So this problem is nice because they give you both the function itself and they give you a graph, so they match. In class, we were practicing as x approaches negative infinity. So this means going to the left. The y values, or the f of x values, this is saying going down. That's correct. For C, also as x approaches positive infinity, so on the x values, we're going towards bigger numbers. That means going towards the right. What's happening to my graph? It should be going up. That's correct. My checks are showing you that both of them are correct. So for example, A is incorrect because as x approaches towards the left, or negative infinity, it is going, this says going up, but my graph is obviously going down. That's why it's wrong. If I go towards the right, is it going up? That is correct. So notice I have an x in the check, but that's not correct. That would have been C. This side was 12 points, 2 points each, 1 point for name and period. All right, on the back side, question number 6, sketch a set of functions. So a set is more than one, whose product, meaning two graphs or functions, that product that multiply, builds a cubic function with the given characteristics. Explain your reasoning. So I need something that goes through -2, +2, and x equals 3. So there they are. Now, the most common mistake was to just draw a cubic function going through those 3. If you did that, then I give you 2 points. Or if you just drew a cubic function, I give you 2 points because you understood the problem asking you for a cubic. But I need a set. So here's my -2 and 2. I decided to draw a parabola. Does not matter if it's opening up or down. And then I drew a linear at 3. You could have done 3 linears is fine. You could have done a parabola here and then a linear. And then explain your reasoning. So explaining gives you that 4th point. Linear times a quadratic function equals a cubic function. So you needed some kind of sentence, or a linear times linear, whatever you did. That's how I worded the points. Let's look at some student work. A linear and a quadratic. If I combine the linear and quadratic, it's a cubic. It says 4 points. Not sure why it has a question mark there, but there's some student work. For students, I circle the word set because that means you need multiple. There's a cubic. Give them 2 points, even though they went through there. They tell me 3 real zeros, but they don't tell me how they're building this by multiplying. This problem is correct, but no explanation. That's why I circled it and gave them 3. Question number 7, fill in the blank square so that each row, column contain all digits 1 to 4, numbers and cages may repeat as long as they are in the same row or column. These are the Ken-Kens. You can watch another video on that I have on my website, but this was either 4 or 1. 4 points correct, 1 point wrong. Question number 8. Sketch the graph, so one graph of the cubic function. So I know that my end behavior, they're going to be opposite directions, that the product of the function is below. So let me zoom in if I can. The first things I'm going to do is I drew, based on the x-intercepts, here, here, and here, those where the graphs cross, I have some dots. And there I drew those blue lines. Now within those regions, so the left of the region, so there's 3 lines, so there's going to be 4 regions. 1, 2, 3, 4. And between those regions, I drew this yellow line. And so here, this is a positive because it's above the x-axis. I drew a positive here. This is a positive, so positive times a positive. And this one down here, this graph is below the x-axis, so it's a negative. Positive times positive is a negative. So that's why my purple graph has to be in a negative region when I draw it. Then between these 2 blue lines, I have a positive. This is below. This is 2 negatives because there's 1 line and another linear. So positive times negative is a positive. I drew my answer down here. So that means my graph has to go above on that part. And then again, you're going back through the x-axis. Then here in this region in yellow, I said a positive times a positive because there's 2 lines, and then going negative. So that means it's a negative. And then the last one, over here on the yellow line that I drew. You can draw that yellow line anywhere you want. There's a positive times a negative, which is a positive. And so I have a cubic function starting down, ending up. So I'm starting down and I'm ending up. It has to go through the x-intercepts, and then by multiplying them, it tells me where I'm going, either above or below. So if you got the wrong end behavior, maybe you're starting up, ending down. But you got a cubic, you just drew a cubic function, or you knew it goes through those x-intercepts, and I gave you 2 points. 3 points if it's cubic and goes through, but maybe you're wrong end behavior. Let's look at some work. Okay, here's a student work around. I gave them 2 points. Even though they went through the x-intercepts, the end behavior is incorrect. I like this work, starting down, ending up, full credit. I like here where they just drew, it looks like they recognize this graph is positive. To the left of those dotted lines, positive, and then they wrote negative, so I like seeing that. Question number 9 says, draw a polynomial function with the following characteristics. So a polynomial function is just one function, but we were talking about in chapter 5 how to build them, either that cubics or quartics through linears, quadratics, and other things. So the characteristics are, as x approaches positive infinity, so that's going towards the right, f of x values, the y values are going to go up, and as you go to the left, it's going to go down. So that means you start down, end up. Then the y-intercept of -2, there's in pink, you have to go through that point. 3 x-intercepts, so I just arbitrarily put those points anywhere. I thought it was easiest to just draw them on one side of the pink y-intercept. And then 2 relative extremas, that just means 1 max and 1 min, or anything like that. I gave you 4 points if you were all correct, 0 wrong. I gave you 3 points if your graph had 1 mistake in there of the 4. And then 2 points if you had just something like 1 correct, 3 are wrong. All right, the student got 3 points. I marked their end behavior incorrect. But notice how it goes through the y-intercept and has 3 x-axis. Now that I'm looking at this problem, it actually has 3 extremas, so really the student should have gotten 2. All right, this student went through and did some check marks, but they realized that, yes, they have a y-intercept of -2, but they missed their x-intercepts there, so they only have 1, so I gave them a 3. Question number 10, for f of x equals x to the third plus 4, number 1, write the rule for each of the function. Number 2, describe the transformation. So a lot of you said, well, it shifted up 4 units, but this is just the function itself. Don't think that's anything has happened. So this one is saying if I take f of x, which is in yellow, and within this function, I have a new function, g of x, I'm going to put f of x there, but every x value I'm going to subtract 2. Well, remember this is the inside, the letter is C here. This is a horizontal shift. Remember my phrase, add to x, go west, you're not adding, so you're not going left, you're going right 2 units. So that would be the describing the transformation. So what do? You take your yellow value, like I did right there, and then for every x value, I tried to show a pink right here, you're going to substitute in x minus 2. So there it is, x minus 2 for every x value. Well, then you need to simplify. We've already talked about that in class. This was a lot of your questions you've seen from previous quizzes, and the question is, have you been watching those previous videos? So x minus 2 to the third power is not x cubed, -2 cubed, like plus 8. So x cubed plus 8 would have been incorrect. You need to take this x minus 2 and multiply it 3 times. 1, 2, take that answer. Multiply again, there's your third one, and you multiply it, you get x cubed minus 6x squared plus 12x minus 8. And then I put this in blue, the plus 4, because you have to put that there. And then you combine like terms, and this is your answer. So if you did the substitution, I gave you 2 points. Or maybe the rest of the problem's wrong, or the rest of the problem's wrong, and you knew that you were being shifted over to the right 2 units, I gave you 2 points. That side was out of 20, and remember the test was out of 32. Let's take a look at some work. Here the student got 1 point for trying. Again, they thought that was up 4 units. This was incorrect, down 2 units. They didn't understand the A, B, C's, and D's. Here's a student has a long explanation. They tried hard, but I gave them 1 point. Even in their transformation, they understood the C value, but C value they interpreted wrong. This problem shows all the work, even though they were messy. Probably lost a point for that, but they show you all the work for that problem. Here they got the 2 points for knowing it's going to the right 2, but here you see substitution was incorrect. That 3 should be on the outside.